Good afternoon. So today we are going to start our new topic. So that is about what? So this is about effective mass where we will see first what energy versus K diagram. Okay, energy versus K diagram for what? For free particle. For free particle or the electron in the free space. Okay, for that we will see energy versus K diagram equation for what parabola. Then after that we will derive this, means we will define the differentiation. Okay, so with respect to K. Okay, so then after that we will apply that result to conduction band and valence band to check whether the electron has what effective mass, positive, negative or zero. Okay, so let us see here. First is what? Ek diagram. What? Ek diagram for what? Free particle, or you can say electron in the free space. For free particle, okay, so or you can say electron in free space. Where? In free space. Electron in free space. Okay, Ek diagram for free particle or electron in free space. Now see here, as we know very well from energy versus momentum equation, we know kinetic energy is equal to what? Kinetic energy of particle is equal to what? Half of mv square. Okay, so now just multiply it both numerator and denominator side by what? Mass. You will get mv whole square divided by 2m, which is further equal to what? V square by 2m, which is further equal to h cut k whole square divided by 2m. Okay, so now this is what? Energy versus momentum equation. Okay, so this is equal to, finally we got h cut square k square divided by 2m. So this is my equation, final equation. Okay, so because we know p, this momentum is nothing but h cut k is equal to mob is equal to h by lambda. Okay, so just you remember this one. Okay, so this is what momentum, this is what energy. Okay, energy. So now as we know, this is what something, this equation, this E is what? Proportional to here k square, momentum square, but this k is not exactly directly momentum, it is related to momentum of free particle. Okay, momentum of free particle. So this is like E is equal to what? Constant c k square. Okay, so this is what? Equation for what? Parabola. Okay, along y axis. So this is my ek diagram. Okay, so this k is here. Actually this is what? So this is wave propagation. wave propagation Wave propagation. This is actually wave propagation vector. Okay, so this is actually a wave propagation vector. So this is not directly momentum, because it is k is nothing but, here it is k is equal to p by h cut. Okay, so we know p is equal to h cut k. Okay, here k is related to momentum of what? Free particle. Now differentiate this with first time. What you will get? We will get dE by dk is equal to how much? dE by dk is equal to h cut square into 2k divided by 2m, which is nothing but dE by dk is equal to h cut square k divided by m. Just take one h cut this side. What you will get? 1 by h cut dE by dk is equal to h cut k divided by m, which is further equal to p by m, and which is further equal to mv by m. Get cancelled is equal to v. Then finally we got 1 by h cut, 1 by h cut, h cut d by dk is equal to what? V. This is my h cut. So this is what, let us say this is my equation. This is my equation number 1. So this is what v means. This is velocity of particle. Okay, so velocity of particle. So this is rate of change of energy. So this is what d by dt, 1 by h cut d by dk is equal to v. It is a velocity of particle. Okay, so now this is my equation first. Now for second just differentiate this, differentiate again this. Okay, so then what we will get? So from there we will get final answer for effective mass. Okay, so just note it down. Okay, so then we will go further. See here, so I'm going to run it. Okay, so see, now what, now we are going to get second derivative. This is our final result. Okay, so that we will apply to conduction band and valence band. Okay, so now see here. So when we differentiate this with second time, see here, this is what is equal to h cut square k square divided by 2m. Okay, so when you will differentiate with second time, you will get dk square d square upon dk square is equal to what? h cut square, 2k 2k into what? K differentiation 1 divided by 2m. 2 get cancelled, you will get h cut square by m. So this is what, so this is nothing but d square e divided by dk square is equal to h cut square by m, second derivative. Okay, so now just take this h cut square that side, 1 by h cut square d square e divided by dk square is equal to what? 1 by m. Okay, so this is my equation number 3. Okay, so first equation is this one. This is my equation number 1, and this is my equation number 2, and this is 3. These result we will apply to what? We will apply to effective mass of electron in conduction band and valence band, to find the effective mass of electron in conduction band as well as in valence band. Okay, in valence band. Okay, so these are equation. Okay, so now see here, if we will draw the graph corresponding to this derivative, so this first derivative will come. See here, this is what? de by dk curve will come, straight line that will pass through origin. Okay, so which slope, how much the slope is here. If we will differentiate this, what you will get? Slope h square by m. Okay, h square by m, h square k you will get h square k by m as what? Slope. Okay, so this is what? Slope of this first derivative. So this is horizon. Okay, with respect to what? K. In second derivative, what you will get? Just constant. This is my second derivative, d square e upon dk square. So what is slope here? That is h square by m. So this is my h cut square by m. Okay, so this is what? This is the curve for this energy versus momentum curve, parabolic. When we differentiate this first time, we will get this. When we will differentiate this second time, we will get constant. Okay, So these all result we are now going to apply in conduction band and valence band. Okay, so means inside the crystal, this is outside the crystal. Okay, whatever we have drawn here, energy versus diagram, that is for the electron which is present at outside the electron, outside the free space, sorry, outside the free space, means it is for free particle. Okay, all these results we are going to apply where, inside the crystal, in conduction band and valence band. There we will check, there will be, we will check what, we will check the effective mass of what, effective mass of electron. Okay, effective mass of electron in both conduction band and valence band. Okay, so now let us apply fast, we will do fast. Okay, so see here. Now effective mass, that is what, effective mass, effective mass, effective mass of electron in conduction band, in conduction band. Okay, effective mass of electron in conduction band. First what we will assume that the electron is near the bottom of the allowed energy band. Okay, let us assume that the electron is present at near the bottom of the allowed energy band, or at the bottom of the conduction band. Okay, so bottom of the conduction band, let us assume that. Okay, so now we are assuming, so this is my what, conduction band, this is my actually what, this is my wave function, actually wave function corresponding to what, corresponding to energy band, allowed energy band, where in conduction band. Okay, so that we have got from where, chronic penning model, there you will see it properly how it is, how it form. Okay, so from there you will get idea. Okay, so this is actually wave function which is not parabolic, it is sinusoidal. Okay, corresponding to what, corresponding to allowed energy band, allowed energy band. Okay, so this is my EK diagram. Okay, so now we are assuming that some electron are available at the bottom of allowed energy band, that is nothing but conduction band, at the bottom of conduction band. Some electron are available. Okay, some electron are available here. Okay, so now the energy, now the energy near the bottom of the allowed energy band, or allowed energy band, or at the bottom of the conduction band is approximated as parabola, is approximated as parabola. Okay, so this is my parabola. Okay, so this is actually sinusoidal wave function corresponding to allowed energy band, and this is my approximated parabola of energy. Okay, so of energy. Okay, energy of what, these electron. Okay, these electron is where, in quantum state or energy state. Okay, so that energy has what, this type of curve, we are approximating it as what, parabolic curve. And the equation of this parabola is what, e minus ec, e minus ec is equal to what, c1 k square, c1 k square. Okay, so this is the equation of what, parabola. Okay, which is approximated. Okay, for this electron which are available near the bottom of the allowed energy band, or bottom of the conduction band. Okay, so now this is my equation. Okay, approximated equation, just for the sake of finding the effective mass of electron in the conduction band. So let us say this is my equation number 1. Now differentiate this equation. First time what you will get, d by dk is equal to, d by dk is equal to 2c1 k. Okay, so now see here, from here e is greater than ec, e is greater than ec. This implies that what, this implies that c1 is what, c1 is positive, c1 is positive. Okay, so from here you can, this is what, is energy is greater than ec. Okay, ec. Okay, so now from here c1 is greater than 0, means c1 is positive. Okay, c1 is positive. This is my ec, edge of the conduction band, edge of the conduction band. Okay, edge of the conduction band. This E is greater than EC. Okay, so because this is my total energy, above energy, this is lower what at the energy at the bottom of conduction band. That's why E minus Cc. E is greater than Ec. C1 is positive. Now differentiate this second time. What you will get? D square E upon dk square is equal to what? Is equal to 2c1. 2c1. So this 2c1. Okay. So now see here, as we know from what, from previous analysis of energy versus k diagram for free particle. So what we got there? D square E upon dk square. Okay, so just multiply it with, divide it with 1 by h cut square, and this side also divide it with 1 by h cut square, and this become equal to 1 by mn star. What? Mn star. Okay, so as we have seen in previous case. Okay, which case? The ek diagram for free particle case. Okay, we have seen this. Okay, so this is what 1 by h cut square d square d upon dk square is equal to 2c1 by h cut square is equal to 1 by mn star. From here, what you can write? Mn star. Mn star is equal to what? Is equal to h cut square divided by 2c1. Yes, 2c1. Or you can write it as what? H cut square divided by d square e upon dk square. Okay, so this is my effective mass where in conduction band. This C1 is what? C1 is greater than 0, means it is positive. Then this means what? This means effective mass of electron in conduction band is positive. Effective mass of electron in conduction band is positive. Is it visible? This side? This side is it visible? Okay, if it is not visible, let us write here Mn star is equal to what? H cut square divided by 2c1 is equal to h cut square divided by d square e upon dk square. Okay, so dk square. So this is what? Effective mass of what? Electron in valence band, where mn star effective mass. This is what? Positive. This is positive because what? C1 is greater than 0. This implies that effective mass of electron is what? Positive in conduction band. Now we are confirmed. About what? About effective mass of electron where in conduction band is what? Positive. Okay, so this only we want to confirm. Okay, now we are confirmed that the effective mass of electron is positive in conduction band. Okay, this curve is not actually parabolic curve. Okay, so it is a sinusoidal curve, which is a wave function. What? Wave function. Okay, wave function means this is actually electron particle in the form of wave. Okay, particle in the form of wave, as we have seen wave particle duality principle. Okay, so this is from there. Okay, so this is what? Wave function corresponding to energy. Which energy? Allowed energy. Okay, so this. So here we have assumed the energy of this electron, which is available at the bottom of the allowed energy band, is approximated as parabola, whose equation is given by this. Then after that we have differentiated this second time, and okay, first time, second time we got this d square upon dk square. After that multiply it with both side 1 by h cut square, 1 by h cut square, it become 1 by mn star. Okay, as we have seen in the last case of what? Free particle. Okay, we have applied all these result here, and from here we got what? The effective mass of electron is what? Positive in conduction band. Okay, now, and if we apply what? Force. Okay, if we apply the force for the applied for the if we apply electric field for the applied force. Okay, or if we apply the force for the applied electric field, we will get force is equal to mass into acceleration. This is mass mn star into acceleration, which is equal to electric field. Electric field is nothing but charge into what? That this is what? Force is equal to charge. Charge is what? Electron minus E into E, electric field. Okay, from here acceleration is what? Acceleration is nothing but minus E divided by mn star, divided by mn star, mn star. Okay, so this is my acceleration. From here, from here, what you will observe that the moment of electron is in opposite direction of what? Moment of applied electric field. Moment of applied electric field. This is because of what? Because of negative sign of electron. Okay, negative charge of electron. Okay, so this is all about the effective mass of electron in conduction band. Okay, so now next we will see what? We will see about, see, all this result is important. Okay, so just note it down. Okay, then we will go for next is what? Next is effective mass of what? Effective mass of electron in valence band. Is it positive, negative, or zero? Okay, so just think about it and we will come to know. Okay, after deriving, okay, after applying all this result to the valence band. Okay, similar like conduction band. Okay, just only the difference is that there the curve is negative, here it is positive. Okay, so now we will see. So this is for what? Effective mass of electron in the conduction band. Now we are confirmed what is that? That is positive. Okay, so this is all about this. Okay, we will come to next. Next is what? Next is first we will see concept of hole, concept of hole. Then after that we will come to what? Effective mass of electron in valence band. Okay, by applying all this result. Thank you very much. Okay.